Hi everyone, my name's Peter Drown. I'm an MBA student here at the University of Maine. I just completed my undergraduate here in economics, and I've been working at the Advanced Structures and Composites Center on the Deep Sea Wind Project, where we're looking to deploy deep water floating offshore wind turbines in the Gulf of Maine. So I've had a little bit of experience learning about renewable energy firsthand, and I've been doing a lot of private research on my own, kind of studying the economics and how that relates to renewable energy. So I'm really excited about this topic today. I really think this is an important issue for our generation to learn about. So here goes. So I'm here to give you a quick introduction about what I know about renewable energy and how it relates to the economics. So when we talk about energy, we basically get our energy in the United States from one of two sources. We either get it from renewable sources, we get them from fossil fuels. The vast majority right now comes from fossil fuels, and the majority of that amount comes from coal. We get about 40% of our nation's electricity supply from coal. We get about another 30% from natural gas, and we get smaller amounts from oil, wind, solar, geothermal. These are all the renewable sources, and we get about 15% of it from nuclear right now, and we get another amount from biomass. The reason I put these two in the middle is because they kind of fall in between renewable and non-renewable sources. Nuclear is really a non-renewable source. However, it's not really a fossil fuel. That is, it doesn't come from organisms that have been decaying in the earth. The major difference between renewables and non-renewables is that renewables come from Earth's forces. So gravity, the sun, the heat from the core of the earth. And non-renewables come from fossil fuels, which means forces that are from organisms that have decayed over thousands and thousands of years into deposits of oil and natural gas and coal. So that's the major difference between renewables and non-renewables. And now I'm going to talk to you about why we like renewable energy and what are some of the issues facing that industry, and also how we're working to kind of solve some of those issues. So the first reason that we love renewable energy so much is that it's clean, right? Unlike fossil fuels, which produce greenhouse gas emissions, renewable energy is clean. And there's a lot of political debate these days about what constitutes clean and whether it's really important to have clean energy. And there's a debate about whether global warming even exists. Well, I'm going to submit to you today that maybe it doesn't matter that global warming exists. Maybe it does. Maybe it is warming. Maybe it's not. Maybe the Earth is increasing. Maybe the temperature is, and whether it's not. But that's not the bigger issue with climate change as a whole is the number of global weather anomalies. That's a term that basically describes what are the severe weather events that have been going on with more and more frequency over the past 50 years or so. And if you look at a graph that shows time on the x-axis and weather events, extreme weather events on the y-axis, you'll see that kind of going along throughout recent history. Say this is the 1900s. So this is very recent history relatively in terms of the age of the Earth. And then you hit the 1960s. And all of a sudden, throughout the 1960s until now, we've seen the number of extreme weather events triple. Okay, and this is a very significant development. And the reason it is because each of these weather events, whether it be a tornado or a flood or a tsunami or a hurricane or fires or droughts, these extreme weather events all carry a significant price tag. So it's more than just an issue of climate change and whether we're altering our environment. Each of these events that happens has a very significant and very real price tag attached to it. So dealing with these weather disasters, whether it's having to replant crops, whether it's having to clean up after a tsunami or a tornado or whatever, they all carry a significant price with them. So there's an actual real economic effect from climate change that's not just the actual environmental effect. So that's affected by the environment. So the main issue, this is one of the main issues with why we want clean energy. Another issue is the health aspects of it. And it's well known that if you go to like Beijing, China, for example, there's smog covering the city, that it's pumping out coal to keep up with the pace of development in the city, and that you see that throughout a lot of very populated cities. And using all this coal and natural gas and oil to produce energy, produce emissions, it creates this greenhouse gas effect, but it's much more concentrated around where those cities are. And that causes a lot of health problems for people that live in those areas. So you see a higher incident of lung disease like asthma, breathing problems. You also see when you're depleting the ozone, you see a lot of effects, sun-related effects like skin cancers, extreme sunburn, stuff like that. So there's a lot of effects, and that doesn't even include contaminated drinking water from emissions and there's a whole slew of health problems that are associated with producing emissions. And that's one of the advantages of renewable energy, is that you don't have those emissions. And the final problem that fossil fuels create when you're burning fossil fuels to create energy have to do with agricultural yields. And these are the effects of fossil fuel emissions greatly altering the environment, altering the amount of rainfall we get, altering the amount of fires we get, creating droughts. And these have a very significant effect on agricultural yields. So the production that a farmer would traditionally get out of, say, an acre of corn, for example, may change from year to year depending on the weather pattern. Well, the increase in these global weather anomalies, this effect called global weirding, is really starting to cause a lot of these agricultural yields to decrease, which also has a very significant price tag to it. So as you can see, all these effects that are as a result of burning dirty fossil fuels have a very significant cost associated with them. That's not represented in the price that you pay. When you flip your light on, you're using electricity that's produced by coal, you're paying a price that's a lot cheaper than the actual price that those forms of energy really bear. So that's the first. So the second reason that we really like renewable energy is that the fuel is free. And you might say, wait a minute, I thought renewable energy was more expensive than fossil fuels. And you're actually right. The price that you pay for renewable energy right now is generally a little bit higher than fossil fuels. And that's not true everywhere in the United States, but it's true in most places. So how come if the fuel is free, why do we pay more for the actual form of energy? And to show you that, I'm going to show you an equation that represents the cost of energy that you pay. And we're going to look at it and try to dissect it and figure out how we can reduce the cost of renewable energy. So the entire cost of energy can be represented by this equation. So the total cost of the energy divided by the annual energy production, that's how much energy you're getting out of your wind turbine or your wind farm, your solar farm, equals your cost of energy. So if we're trying to reduce this number, you can do one of two things or you can do both things. You can reduce the numerator or you can increase the denominator. Both of those will have a decreasing effect on your cost of energy. So if we're trying to decrease the numerator, we're talking about the total cost for renewable energy, right? And there's two major costs that are associated with that. So we have our fixed cost, which in energy generation terms is called your capital cost. And we're going to abbreviate that CapEx. And then we also have our operating costs, which are OpEx. And these would be, in economics, that would be your variable cost. So you have your capital costs and you have your variable costs. This is true for coal as well as renewable energy. With capital costs in renewable energy, it's affected by a number of different factors. When you're, the materials that go into renewable energy systems, whether it be a wind turbine or a solar panel, a lot of the materials are called rare earth materials. So the materials that make the magnets that cause electricity from the wind turbine or go into the solar cells. They're very advanced materials, and a lot of them are based off rare earth metals that come from places in the earth that are very geographically dispersed, that may come from countries that don't have a particularly stable political environment. And in order to extract those materials and use those in these wind turbines and the solar panel, it actually causes the cost to increase quite a bit. So that's one of the main reasons that the capital cost is higher. So what engineers are learning how to do is how can we find cheaper ways of producing those materials, or how can we get the same sources of materials from the same places and extract them in a cheaper manner, or secure the supply a lot easier. So those are two ways that we can reduce the capital costs. With operating costs, the advantages of renewable energy is that they're very low. Operating costs just are the cost that after your plant is already up and running, what do you have to pay to keep that plant running? So with a wind turbine or a solar farm, you basically just have to keep going to the wind turbine or the solar farm and doing routine maintenance on the farm. Maybe you have to replace a blade, maybe you have to replace a generator, and it's just this basic routine maintenance. With a coal plant or an oil plant or any plant that uses fuel, you have an additional cost, and that's the cost of your fuel. So you have to keep buying fuel to power your turbine, which is producing your electricity. So if we want to display these two costs side by side, a good way to look at it is this. Here we have time, and here we have cost. And as I said, the capital cost for renewable energy is quite a bit higher than it is for fossil fuels right now. So let's say our renewable energy is right here. This is our renewable energy. And let's say our fossil fuels are cheaper initially, so they're down here. Okay, so over time, with renewable energy, you have very minimal operating costs. You don't have any fuel. The wind is free until somebody learns how to put a price tag on the wind or the sun or the heat of the earth. It's all free. So it's very low. With fossil fuels, that cost increases over time because you have to keep buying the fuel. And the concept is that at some point in time, the renewable energy system, renewable energy plant becomes more cost effective than the fossil fuel plant. And every point past here are cost savings for the renewable energy plant. And these are a lot of the reasons that utilities have purchased renewable energy generation assets. They understand that fossil fuels, they are going to have to keep replenishing the fuel, and the worst thing about fuel that you buy for fossil fuels is it's a very volatile price market. So the price does not maintain this smooth price trend, right? That would be ideal if we just knew that the price was going to be X amount for a period of time. You just keep buying the fuel and it would gradually increase. But in reality, the fossil fuel prices fluctuate quite a bit. It may spike up, and that may cause this line to go way up here. And the problem for the utilities is they have no idea when these price spikes are going to occur. So they can't plan for it, and that uncertainty costs money. So that's the reason why renewable energy systems can become cost effective with fossil fuels. And the final note I want to mention about this is that the biggest reason that renewable energy is right now is a little bit more expensive than fossil fuels is because it's newer. And you see that with any technology on the face of this earth. Whether it's a cell phone or computer, any gizmo gadget that you have, it's always more expensive. The early adopters to that technology, the people that first produce that, always pay a premium, and the people down the road get to reap the cost benefits that are associated with the learning cycle. So with fossil fuel plants, there's countless manufacturers. The supply chain for fossil fuel, that is the people that produce the parts that go into a fossil fuel plant, have been doing this for years. So they've perfected their manufacturing processes, they've secured their supply chains, they know exactly the best way and the most cost-effective way to produce these parts. With renewable energy, they're still kind of figuring it out. So that's the biggest reason why the cost is more expensive. And as time progresses, we're going to see the cost gradually decrease. And we actually already have. We've seen that tremendous amount in solar energy right now. We've seen the cost come down dramatically. With onshore wind, we've seen costs come down to where it's actually cheaper than coal in certain places. So we're definitely seeing these cost reductions.